Today we'll be walking you through the Charder Body Composition Child Results Sheet. At the top of the results sheet, you'll see the child's name, ID, height, gender, age, and more. As normal ranges for children can change significantly with even a year's difference, it's important to make sure birth date is input correctly, and also that you don't have the wrong child's results sheet in your hands. At the right of this section, you'll see the child's total body weight. On this results sheet, body weight is divided into 4 different compartments you see on the left. Let's start with total body water, or TBW. This is all the water in the body and generally correlates with muscle mass, as muscle is high in water content. Normal range for total body water can be found on the right for reference. The next compartment is protein. When you add body water and protein, you get soft lean mass, or SLM. Basically, you can think of it as the amount of muscle in your body. This includes muscle that cannot be consciously controlled, such as cardiac muscle and smooth muscle. Normal range for protein can be found on the right for reference. Next, we have minerals. Note that this is the weight of minerals in the body, most of which is contained in your bones. This is not the same as bone density. To get a bone density measurement, a DEXA scan may be necessary, though generally difficult for children to get. Normal range for minerals can be found on the right for reference. By adding minerals to soft lean mass, you get fat-free mass. As its name makes clear, fat-free mass is the weight of everything in the body except for fat. So if you add body fat mass to fat-free mass, you'll get total body weight. As mentioned earlier, we provide reference ranges for the various compartments on the right-hand side. But in general, we'd recommend using the other parts of the results sheet, as they're designed to be easier to understand with comparisons to place results in context. This section is fairly straightforward, but very useful. It looks at the amount of muscle and fat in the body and tells you if it's under, normal, or over for the child's height and gender based on the length of the black line and where it stops. The first line will have the same total body weight that can be seen on the top right of the results sheet. Note that normal here is calculated based on body mass index, which will automatically adjust according to the child's age. The second line is skeletal muscle mass, SMM. The difference between skeletal muscle mass and soft lean mass from the section above is that skeletal muscle mass is the muscle used to move the body and can be developed actively through nutrition and exercise, in contrast to smooth muscle or cardiac muscle. You may need to observe carefully if a child's result is in the under range for their age group for an extended period of time, as it may be a sign of delayed growth. The third line is body fat mass. Just like the lines above, this shows if the child's body fat is under, normal, or over. Ideally, a child's body fat should be in normal range, as body fat that is both too high or too low can have negative long-term effects on their health. Next is the Obesity Analysis section, which includes percent body fat, body mass index, and waist-to-height ratio. In this section, percent body fat is divided into under, normal, over, and obese. Note that the number markings above the black line mean body fat percentage. So in this example, normal range for this child's age group is between 12.8% and 22.2%, so their result of 13.4% is normal. Normal range is not static and will change as the child grows older. Research has indicated that childhood obesity has a high correlation with obesity later on in life. As such, if a child's body fat exceeds normal range, it's a good idea to try and control body fat to reduce health risks in the future. Something to be aware of is that because children are lighter in weight, small changes in body fat mass can result in seemingly large changes in percentage. This is normal and we recommend observing trends over a period of time rather than focusing too much on an individual result. Body mass index, or BMI, is one of the most common methods used to calculate obesity risk. It's commonly used because it's relatively easy to calculate. All you need is height and weight. The problem with BMI is that it doesn't distinguish between the source of weight. So, two people of the same height and weight will be categorized as having the same risk level, even if one person is mostly muscle and the other person is mostly fat. It's also important to note that child and adult BMI standards are not the same. Child standards will change with age, particularly during adolescence. Lastly is waist-height ratio. The purpose of this section is to help evaluate obesity risk. How does it differ from body fat percentage? Well, not all body fat is equal. Normal waist-to-height ratio for children is between 0.4 and 0.5. If waist-to-height ratio exceeds 0.5, it may be to excessive subcutaneous fat, and if it exceeds 0.6, it may be a sign that the child has too much visceral fat, and an adjustment in diet and activity level may be necessary. Using the three different methods of fat analysis together, you can determine the child's whole body and abdominal fat level. If multiple indicators are over normal, it may be a warning sign for obesity-related problems. On the right side of the result sheet, we have the growth chart, with several different national standards available for use. In this example, we've used the World Health Organization's height and BMI percentile standards. How do you read a growth chart? The measurement point on the chart indicates the result for the child being measured. The percentile number means that the child exceeds that percentage of children their age for that measurement. So, for example, if the child is in the 75th percentile for height, they are taller than 75% of other kids their age. It's important to note that following the child's height and BMI at different ages and seeing if it follows a consistent growth curve is more important than what their percentile is at any given point in time. For example, even if a child is at the 15th percentile for height, which means that 85% of kids their age are taller than they are, if they've always been in the 15th percentile, that means they are likely growing normally, albeit slightly later than others, or slightly smaller than others. However, if a child was originally in the 50th percentile and has fallen down into the 3rd percentile, then that may be a sign of growth abnormality. These are the growth charts offered on the child results sheet. The higher one is for height, and the lower one is for BMI. Next is growth history, one of the most important parts of the child results sheet. This allows you to track the child's height percentile, weight, BMI percentile, skeletal muscle mass percentage, and body fat percentage for the last 6 measurements, making it easy to see if they are continuing a normal growth rate. This section combines the various body composition results and combines it with growth percentiles to provide nutrition and activity recommendations. Using the child in this results sheet as an example, all the results in both nutrition and growth evaluation are normal. The recommendations provided will automatically adjust based on the child's results, which can then be used by professionals to provide guidance and advice. Next, there are a few more advanced outputs that are less commonly used but can be rather useful. First is phase angle, which is typically only found on more advanced BIA scanners, used for measurement of cellular quality. You can think of this as the strength of the body's cells. Phase angle decreases with illness and age, and it's an important indicator of overall health status. If the child's phase angle gets lower and lower over a period of time, that's a possible sign that something odd is going on with their body, and we recommend getting a more detailed health check. As less research data is available regarding face angle for children, we recommend consulting a professional for interpretation. Next is basal metabolic rate, or BMR. Because children naturally have higher metabolism compared to adults, there used to be a mistaken belief that any nutrition consumed will be used to help build the body. However, even for children, excessive caloric consumption can still overburden the body, increasing risk of metabolic diseases. As such, more attention is being paid to proper nutrition and calorie count. BMR is a good tool for helping to calculate how many calories someone will burn each day. Do note that you actually use more energy each day than BMR, because in addition to energy used to keep the body alive, energy is also used to move around, digest food, and use your brain. You can multiply BMR by activity level to estimate daily calorie expenditure and plan how much to eat each day accordingly. Waist-hip ratio and subcutaneous fat area are related to general fatness, but because children display much more variation compared to adults as they grow, we recommend using the waist-height ratio as a more useful marker of potential obesity, and that waist-hip ratio and subcutaneous fat area should be used for anthropometric and BIA research instead. Total body water and fat-free mass proportion is fairly stable at around 73% for most adult populations, and significant deviation is generally seen as an indicator for abnormality. That said, because it is relatively normal for a child's body water to fluctuate significantly compared to adults, this should be used for general reference only. Lastly, we have impedance. This isn't really something you need to worry about, as it's part of the raw data the device uses to perform body composition calculations. Just remember that if results seem to be noticeably strange, make sure you have your impedance results available for our professional consultants to analyze to determine if something's wrong.